Hello my dear friends and welcome to our today's class. It's our third lesson on the fifth topic of Form 3 work, which is called Current Electricity 2. As usual, let me comment by giving you the quote of the day, which states that the greatest discovery of all time is that a person can change his future by simply changing his attitude. We shall discuss that quote at the end of our class today. So today we are looking at the electrical resistance, and we are saying that electrical resistance simply refers to the opposition offered by a conductor to the flow of an electric current. So electrical resistance occurs when a charge flowing through a conductor has its movement restricted by collision with the atoms and impurities in that particular conductor. Then these collisions scatter the charges, leading to loss of momentum and energy in form of heat. So this is a typical conductor which has points A up to point B. So we are considering these charges or the electrons. Remember, when we talk of a charge, we mean either a proton or a neutron. That is a proton or an electron. But we said earlier in electrostatics 1 that they are the electrons which are always involved in any reaction or in any movement, simply because the electrons are usually found within the energy levels of the atom, and therefore they are free to move from one point to another, that is by either being gained or being lost. So when we talk of the charges flowing from one point to another, we are simply talking of electrons carrying the charge from maybe point A up to point B. So consider this particular conductor. We have two electrons which we want them to carry our charge from point A up to point B. So within this particular conductor, we have the impurities and also the atoms. So remember, the impurities and atoms, usually they block the path through which these particular electrons have to flow as they carry the charge. So if these electrons tries to move from point A up to point B, when it gets here, it meets an opposition by this particular atom. So the atom prevents that electron from flowing from point A up to point B. Also, these electrons meets opposition because it collides with the impurities within that particular conductor. So what actually causes electrical resistance is simply the impurities and the atoms within that particular conductor, because they tend to block or oppose the flow of charges from one point to another. So electrical resistance occurs when a charge flowing through a conductor has its movement restricted. So the electrons are restricted from flowing from point A up to point B, therefore they do not carry charge up to point B. So that opposition to the flow of electrical current, that is what we are calling electrical resistance. So these electrons are blocked by impurities and atoms within that particular conductor from moving smoothly from point A to point B. So because they are being opposed from moving, so that opposition offered by the impurities and the atoms within a conductor to the flow of electrical current, that is what we are calling electrical resistance. Then a material with a high conductance usually has very low electrical resistance. Remember, conductance is just the opposite of resistance, because a material which is a good conductor will always have very low electrical resistance. So good conductors usually have very low impurities and very low atoms that tend to block the flow of electrons. So if a conductor has few impurities and few electrons, it means it is a good conductor, because the electrons will have nothing to block them from flowing from point A up to point B as they move the charges. Therefore, a material with high conductance, or a material which is a very good conductor, it has very low electrical resistance, because the charges or the electrons flow within it as they move charge from point A to point B without with very low or minimal opposition from the impurities and the atoms. Then we are saying that this one occurs when a charge flowing through a conductor has its movement restricted by the collision with the atoms and the impurities in the conductor. So remember, as the electrons collide with these impurities, that is these impurities and the atoms, they tend to lose the energy. So the collisions, they scatter the charges, leading to their loss of momentum, that is their movement, that is their velocity is reduced. Therefore, remember, mass times velocity, that is the definition for momentum. So as the electrons collide with the atoms and impurities, their momentum is reduced because their velocity of movement is also reduced. And also as they collide, it also leads to loss of energy in form of heat. That is why if you touch a conductor which is has very high electrical resistance that is connected to the terminals of a battery, that is when the circuit is closed, when you touch that conductor, you will realize that its temperature will be somehow high. That is, you will feel some form of heat, because whenever that is energy, that is electrical energy being converted to heat and therefore being lost to the immediate environment. Then you have said that a material with high conductance has very low electrical resistance. For example, copper. So you'll find that within the copper, that is a conductor like copper, we have very few impurities and also very few atoms. So those very few impurities or negligible impurities, they do not, it ensures that the path for the flow of electrons is smooth. Therefore, the electrons move the charge from point A to point B smoothly. Therefore, it has a very high conductance. Now, from the definition of Ohm's law, or from the graph of V against I that we looked at, we concluded that the gradient of that graph, that is called the electrical resistance, which is the constant. Therefore, from the formula from the Ohm's law that V is equals to IR, we can simply conclude that resistance is equals to the ratio of potential difference to the current. So remember, potential difference is usually measured in volts, current in amperes. So the SI unit for resistance, we did say from our previous class that it is the ohms. That is derived from the Ohm's law. That is because the person who made some contribution to the discovery of the Ohm's law was actually had a name ohm. So the SI unit for resistance is therefore the ohm, which is denoted by this particular symbol here. Then from this particular relationship, we can see that the units for resistance will be equal to the units for potential difference divided by the units for current, which is the amperes. Therefore, 1 ohm, which is the unit for electrical resistance, is equals to 1 volt per ampere. So volt, unit for potential difference, divided by the units for current, which is the ampere. Then electrical resistance is measured by an instrument called an ohm meter. It is measured by an instrument called an ohmmeter. Then we have a few factors which affect electrical resistance of a metallic conductor. The first factor is temperature. So remember that when you heat a substance, that simply means that its temperature will increase. Therefore, if you increase the temperature of a substance, or when you heat a substance, this increases the kinetic energy of the atoms within that particular conductor, thus making those atoms to vibrate more. So the vibration increases the collision per cross-sectional area of the conductor, hence the opposition to the flow of electrons thus increases, and hence an increase in temperature will always increase the resistance of a metallic conductor. So consider these are my atoms. So when you increase the temperature of this particular conductor, the atoms within that particular conductor, they will gain kinetic energy. Remember, kinetic energy is the energy in motion. Therefore, if the atoms gain kinetic energy, they will start vibrating, that is up and down. So, and remember here we have our electron, which is carrying charge. We want that charge to be moved from point A up to point B. So as these particular atoms vibrate within the conductor, they actually block, or they oppose the electrons from flowing from point A up to point B. And remember, those electrons are the ones which are carrying the charge. Therefore, if electrons do not flow from point A to point B, it simply means that resistance has increased. Therefore, that is how temperature affects the resistance of a material. That an increase in temperature will increase the kinetic energy of the atoms within that particular conductor. Therefore, the atoms will start vibrating up and down, or to and fro, hence blocking the path of the electrons. And if electrons are blocked, it means the charges won't flow from point A to point B, hence increasing the resistance of that particular material. However, this does not mean that the resistance of a metallic conductor, for example, copper, can fall to zero at extremely low temperature. So when we talk of temperature, we only talk of when the temperature increases, kinetic energy of the molecules or of the atoms will increase, hence making them to vibrate. As the molecules vibrate, they block the path of the electrons. Therefore, electrons do not move the charge from point A to point B of that conductor, and therefore electrical resistance increases. However, when the temperature is low, for example, this does not mean that when the temperature of copper falls to 0, that does not mean that the flow of electrons or will be totally, that is, that the electrical resistance will be either maybe high or low. So when we talk of temperature, we only talk of increasing the temperature. But when the temperatures are very low, remember, such a material will still conduct some electricity. The material will still conduct some electricity. Therefore, we are just saying that this does not mean that resistance of a metallic conductor, for example copper, can fall to 0 at extremely low temperatures. So conductance, even at very low temperatures, the conductor will still conduct the charges. We got our next factor, which is the length of the conductor, and we are saying that resistance R of a uniform conductor of a given material is directly proportional to the length. This one simply means that the shorter the length, that is the shorter the length. Remember, we are comparing length of the conductor and resistance. So a short length, when the length is short, it simply means that the resistance is also very low. But when the length of the conductor is long, it means that the resistance of that particular conductor will also be very high. So this can be explained in terms of the impurities and the atoms within that particular conductor. So consider this particular two lengths, assuming from point A up to point O, this conductor has a length of 5 centimeters. So you can see within 5 centimeters, we have 1, 2, 3, 4, 5, 6 impurities plus the atoms. And remember, these impurities and atoms, they are the ones that block the flow of electrons. Therefore, if the length is short, that short length has very few impurities and very few atoms. Therefore, if we have very few atoms and very few impurities, it means the opposition to the flow of electrons will be very, very low. Therefore, the shorter the length, the lower the rate of resistance. And the longer the length, remember, when the length is long, for example, from point A up to point B, we are having a length of 10 centimeters. So within a length of 10 centimeters, that conductor has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that conductor has 10, that is number of atoms and also the impurities. So obviously, the more the number of atoms and impurities, the higher the resistance, because the blockage of the flow of electrons from point A up to point B will also be very high. So we can just conclude and say the longer the length of the conductor, the higher the resistance, because of the more the number of impurities and atoms within that conductor. And the shorter the length, the lower the rate of resistance, because a shorter length simply means the impurities and also the atoms that will block the flow of electrons will be very, very low. Therefore, the longer the length, the more the number of impurities and atoms, hence the higher the rate of resistance. But the shorter the length, the fewer the number of impurities and the fewer the number of atoms. Therefore, the lower the rate of resistance to the flow of charge. Then the third and the last factor is what we call the cross-sectional area of that particular conductor. And here we are saying that a conductor with a large cross-sectional area has many free electrons, hence better conductivity or simply low resistance. Therefore, resistance R is inversely proportional to the cross-sectional area A of the conductor. Remember, inversely proportional simply means that the higher the larger the cross-sectional area, the lower the electrical resistance, and the smaller the cross-sectional area, the higher the electrical resistance. So remember, a conductor with a large cross-sectional area, it has more electrons. And if you have more electrons, it means your chances of taking charge from point A to point B will actually be very, very high. So if this particular conductor, which has a larger cross-sectional area, because it has more electrons, it means it will carry more charge from point A up to point B. Therefore, the larger the cross-sectional area, the more the number of electrons, therefore the lower the resistance, because it means more electrons will be able to reach at the other end, point B. However, a conductor with very small cross-sectional area, it usually has few number of electrons. Therefore, if we have few number of electrons, electrons, it means that the probability of the electron flowing from point A up to point B to carry charge up to point B will be very, very low. So in fact, most of the electrons will be blocked from reaching point B. Therefore, the smaller the cross-sectional area, the fewer the number of electrons, therefore the higher the electrical resistance. Therefore, resistance is inversely proportional to the cross-sectional area. And you have said the reason is because a conductor with a large cross-sectional area will always have more number of electrons, hence the ability of electrons to flow from point A to point B as it takes charges to point B will be very, very high. So more charges will reach at point B, hence low resistance of the conductor and therefore high conductance. But a conductor with low cross-sectional area has few number of electrons, and therefore those electrons will be blocked. If you block very few electrons from reaching at point B, it means that if no electron reaches at point B, therefore the resistance is very high because the charge will not be reached at point B. Therefore, a conductor with a smaller cross-sectional area will always experience high electrical resistance because it has fewer electrons. But a conductor with a larger cross-sectional area will always experience very low electrical resistance simply because it has more electrons to carry charge from one point to another. Now, if I combine equation 1 and 2, that is equation for length and resistance, and the equation for resistance and cross-sectional area, I'll have, remember, resistance is directly proportional to the length of the conductor, and also resistance is inversely proportional to the cross-sectional area of the conductor. So if I combine these two equations, you can see that resistance is common in both equations. Therefore, I'll have resistance R is directly proportional to length, but at the same time, it is also inversely proportional to cross-sectional area. Therefore, I just pick 1R. Therefore, R will be directly proportional to length times 1 over cross-sectional area. That is, if I combine these two. So I'm just taking R because it is common. Then I multiply L times 1 over A, which gives me L times 1 over A. Therefore, resistance is directly proportional to length times 1. You just get length, then over the cross-sectional area. Now, to remove the proportionality symbol, we simply introduce equal signs with a constant. Therefore, R will be a equal sign times a constant times length over area. And this constant, we usually call it the resistivity of the material used, or the resistivity of the conductor. Therefore, from this particular formula, we can conclude that resistance is equal to resistivity times the length of the conductor divided by the cross-sectional area of the conductor. If I make resistivity subject of the formula, I'll simply multiply both sides by the reciprocal of length over area. Therefore, I'll have area over length times R is equal to resistivity, length over area times area over length. So I'm simply multiplying by the reciprocal so that I can make resistivity to be the subject of the formula. So of course, area and area will cancel, length and length will cancel. Therefore, I'll remain with resistivity rho being equal to area times, that is the resistance times area over length. Remember, resistance times area, you just get RA, resistance times area over the length. Therefore, this is the formula that we use to calculate the resistivity of the material. Then we can also derive its units for the resistivity. Remember, units for resistance is the ohm, units for area is square meter, unit for length is meter. Therefore, square meter divided by meter, you will just remain with 1 meter. Therefore, ohm times meter, it will give you the units for resistivity as the ohm meter. The ohm meter denoted by this symbol here. Then lastly, I have an example here which reads that a wire for 80 centimeters long has a uniform diameter of 0.56 millimeters. If the resistance of the wire is 10 ohm, determine the resistivity of the material of the wire. So we start by expressing each quantity in its respective SI unit. So we are told that a wire of length 480 centimeters. So that is length. We know that the SI unit for length is meters. Therefore, we convert 480 centimeters into meters. We know that 100 centimeter is equals to 1 meter. What about 480 centimeters? So that will be 480 over 100 centimeter times 1 meter, which gives us 4.8 meters. Then resistance for, we are also given, has a uniform diameter of 0.56 millimeters. But we know that in this case, we'll need the area. And if we want the area, which is pi r squared, we'll need the radius. Therefore, radius will be diameter over 2, which is 0.56 millimeters, divided by 2, which gives us 0.28 millimeters. We know again the SI unit for radius or the length is meters. Therefore, we know that 1000 millimeters is equals to 1 meter. What about 0.288 millimeters? So this will give us 0.288 millimeters divided by 1000 millimeters times 1 meter, which gives us 0.000288 meters. Then they have asked us to find the resistivity. From here, resistivity is equals to resistance times area divided by the length. So resistance, we are given the resistance of the material is 10 ohm. Then the area, remember this is a wire and you are given the diameter. The diameter, that is the wire, is usually in the shape of a cylinder. Therefore, the cross-sectional area is the area of a circle, which is given by pi r squared, then divided by the length of the conductor. So resistance, we are given as 10 ohm times the pi is 3.142 times the radius squared. So the radius, we have already found it as 0.000288 meters. So times 0.000288, that is squared, divided by the length, which is 4.8 meters. So you compute this, you will obtain resistivity of 5.132 times 10 power negative 7 ohm meter. I've just expressed this one into 4 significant figures. Then I have an exercise here that I do recommend you should try to gauge whether you have understood the concept that we have learned in this lesson. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that the greatest discovery of all time is that a person can change his future by simply changing his attitude. So the quote is reminding us that having a positive attitude towards life can change our future from dark to bright. So this is only possible if we tie our positive attitude to every action we choose to do. Because if you do every action with a positive attitude, you will take the right decisions, you will make the right actions, and therefore your chances of being successful will be very, very high. And lastly, recall that we may not have the ability to change how our story began, but we always have the ability to change how our story will end. So you have the ability to change how your story will end by simply taking some positive actions towards achieving your dream. Then again, in case you have any challenge in answering this particular exercise, just drop a comment, and of course I'm always here to help where necessary. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll always get notified. In case you know any student or anyone that you honestly think could benefit from this content, kindly refer them to Kind Tuition Academy. Thank you very much. Until next time, this is Kind Tuition Academy.